We said earlier that we could make a buffered solution of virtually any pH. So how do we choose the components of a buffer system to give the desired pH? So let's say, for instance, a chemist needs a buffer of pH 8. We're going to choose from this list and figure out which weak acid and conjugate base would be the best combination. You might be able to see that pH of 8 is going to be closest to this -8. To make it a little easier, my suggestion is that you go through and you find some pKa's. So minus a log of 1.2 times 10 to the minus 2 is pKa is 1.92. For HNO2, the pKa is 3.40. For acetic acid, the pKa is 4.74, 7.46, 9.25. So what we're looking for is the acid whose pKa is closest to the pH that we want. Okay, so you look, whatever pH you want, look at your list of acids and find whichever one has the pKa closest to the pH you want. Okay, so what we're going to use is HOCl and its conjugate base OCl-, which we would get from something like sodium, the sodium salt. Okay, so now what we need to do is say how much of the acid do we need and how much of the base do we need to fine tune this and get it not to 7.46 but to 8. So if we look at our trusty Henderson-Hasselbalch equation, okay, moles of acid, moles of base, and H plus we're looking for, so pH 8, so that's an H plus of 1 times 10 to the minus 8. We plug in our Ka for HOCl, 3.5 times 10 to the minus 8. And then what we're going to solve for is this ratio of moles of acid to moles of base. Okay, that ratio of moles of acid to moles of base, if we solve for that, comes out to be 0.29 or 0.29 to 1. So if we were to take 0.29 moles of our acid and 1 mole of our base and add it to any reasonable amount of water, we would have a buffer system whose pH is 8. So, to summarize, find the acid whose pKa is closest to the pH you want. Use the Henderson-Hasselbalch equation to find this ratio, which will allow you to get you the ratio of the acid. Sorry, cut off right there. So it'll get you the ratio of the acid to the base, and that's all you need. And you're done.